Good afternoon, good evening, good morning, wherever you are. Thank you for joining us today and taking part in Cambridge Technology's latest Beyond Prediction series webinar, Implementing Enterprise Apache Kafka Platform to Enable Machine Learning. My name is Peter Buckley, responsible for sales at Cambridge. Your other presenter today is Nitin Tyagi. He's our Vice President of Enterprise Solutions, and I'll turn it over to him in a minute. I'm going to give you a quick overview of Cambridge. We've been around since 1999. We have about 450 or so employees globally in India, the US, and Germany. We have about 5 locations in the US and several locations in India and Germany. Again, we've been around since 1999. We have a broad set of consulting services that I'll get into a little bit deeper. But a couple of other significant things. We do have certifications of CMMI Service Level 5, ISO 27001, ISO 20000-1. We're an AWS Advanced Tier partner. We're also a Confluent Focus partner for the Southeast of the United States. We'll get into partners a little bit further on for a minute, but we have many, both in cloud and technology. We engage with technology partners where they add value to our customers' needs, specifically on event streaming, Confluent, who were the originators of Apache Kafka back in the day. We're an Oracle Platinum partner, IBM Watson, Apica for load testing and monitoring out systems for low-code mobility development, ForgeRock and CA for identity access management, New Relic for application performance analytics and software analytics, Atlassian, Tableau, and so forth. We have several competencies, and we're members of other programs within the AWS partner ecosystems. We're at big data. We have big data competency, Oracle competency, and a DevOps competency. We are audited and certified managed services partner program member. We're a channel reseller, marketplace consulting partner, a solutions provider, and we're also part of their well-architected partner program. At this point, I'm going to turn it over to Nitin Tyagi. He'll take you through the technical part of the presentation. I'll be back with you later on, talk about next steps and where we go from here. Again, thanks for joining us, and I'll talk to you in a few minutes.
Good afternoon, everybody. This is Nitin Tyagi. As in today's agenda, we are going to look at event streaming. Look at Apache Kafka, how it works, its integration into your enterprise environments. We'll look at how machine learning platforms could get integrated with Apache Kafka and a few use cases around Kafka and machine learning. But before we get started, I guess the key concept is event streaming. Where did event streaming initiate, and how did businesses essentially get to where we are today? So traditionally, the traditional systems had data at rest, where systems or business systems would essentially put a query, and you essentially the backend system would return a single output. However, this is significantly changing. The business needs are continuously changing with social media, e-commerce platforms to IoT devices and whatnot. So there's so many input systems which are creating data at of different sizes, different times, different frequency. Likewise, the same data is needed by output systems at different times and different needs and different sizes and with different urgency. So that has created a whole need of a streaming processing platform where data essentially is continuously changing, evolving as a business grows. Now let's look at the data infrastructure. How has the data infrastructure platform evolved over the years? The traditional systems we essentially had 2 models, which most of us have worked with. One was the traditional ETL data integration platforms, where organizations moved large amounts of stored data to data warehouses, databases, or Hadoop platforms for data analytics purposes. Now, this approach was highly throughput. It essentially gave high throughputs for data transfer. It was durable, it was persistent, but it also had major drawbacks. It had batch transfers. Once the source systems changes, you had to make ETL changes to all your libraries to essentially load the data back again. It's not uncommon in these platforms that reporting platforms or reports are generated the next day. To surpass this, somewhere in the late 90s and 2000, the messaging platforms evolved, be it messages queue, and there's a huge revolution around. And CT was major part of the services-oriented architecture where a lot of message queues were introduced, and the need was real time. How do you react in real time? Um, However, the challenge with these systems where they're not scalable. Uh, and in addition to that, the data was transient. It did not persist. So that caused additional problems. In case the message queues goes down, there's no way for you to fix it or replay back from history. So we ended up with a situation where you had ETL systems but did not have data in real time, or you have messaging systems which did have data in real time but were not scalable. That over the years has evolved into an event streaming platform like Apache Confluent. Now, these platforms are highly scalable, durable, persistent, and ordered with an ability to capture, analyze, process data in real time. So Apache Kafka was initially founded by a team at LinkedIn, uh, and it offers a streaming platform which help companies easily access data as real-time streams. Today, as we speak, many organizations use this for real time, not just for fleet management or IoT devices, but essentially to enrich using machine learning algorithms and to, to essentially play with data and model in real-time analytics. Now, I'm going to briefly look at how machine learning has enabled so platforms which have event-based streamings and platforms which not have event-based streamings. How have they evolved over times? And we all have experienced this in some way or the other. Let's take the example of a retail use case where it was way back. It was not surprised that we used to see so many products out of stock listed on websites. There's not much of personalization or recommendations engine built into real-time online shopping experiences. The point of sale reports were dated at least a day or two lagging in terms of the real-time inventory or sales information. This has significantly changed over the years. We've seen companies like Walmart, IKEA, Target essentially implementing event streaming platforms, where today you have not just the real-time inventory, you essentially have the inventory. You also know where is the shipment being delivered, where is it in the shipment, and when will it be delivered. So we essentially have come full cycle around real-time visibility into product and inventory, not just the warehouse, but to the point of delivery. A recommendations engine, uh, we work with Amazon personalization. It's a real-time recommendation engine where it provides personalization as people essentially perform the shopping based on their purchase histories. And sales and reporting have been in real time for long. And some of the event streaming platforms have made it enabled. You've seen the similar cases in banking or even in auto and transport instances, which is common. You've seen Ubers or the likes of Tesla with automated driverless cars coming, which essentially provide not only sensor diagnostics but whatnot. Technologies like, but the foundation of all this to enable real-time uh, uh, analysis is even streaming platforms. So we're going to give you a brief of Apache Kafka as we get into the next few slides, and how do you integrate Apache Kafka into your platforms. But prior to we begin with that, I guess the key to understand is what was the motivation behind Apache Kafka, and it's been the traditional way that enterprises have looked at data and data loading. Historically, we have looked at extraction, transformation, data load as a process to load data into Hadoop clusters or data warehouses, enterprises, data marts, and do real-time processing. This has a lot of time-consuming activity. It essentially does not help them react in real time and causes a lot of rework whenever the source systems changes or the data sources changes or new data sources come in. It takes a huge life cycle to get new systems into the platform. Now, this was essentially a primary need where platforms like Apache Kafka have evolved. Now, prior to Kafka, and again, this is a view that I'm sure you could relate to within your own enterprises or your customers that you work with. This is not uncommon for lines of business to have silo applications talking to each other or across lines of business or to third-party SaaS applications, to warehouses, to whatnot. This is a classic and layout of any enterprises if you can take it. What an event streaming platform does or enables is to streamline this whole set of applications using an event streaming platform into contextual event driven applications. And we'll get into specifics of what contextual event driven applications are and what difference do they make. But the key to implementing these in your organizations is a paradigm shift. You essentially are used to, and I think most of us are used to looking at individual apps, writing data to data warehouses, and then building data marts or data lakes to it. However, when you look at Apache or a streaming platform, it essentially is the mechanism of how systems speak to each other. The producer, the consumer, the streaming platform, the needs are very different. It would take a paradigm shift for organizations to implement streaming platforms. However, the shift is difficult but needed for businesses to survive in today's world. Let's give you an overview of how Apache Kafka works. Now, at a very high level view, Apache Kafka is a distributed data streaming platform, and it has three major components: a messaging system, essentially a publish, subscribe to stream of records; a storage system, which writes records to disk and replicates for fault tolerance; a streaming process, which processes streams for records as they occur. And you should note that Kafka runs as a cluster, which stores streams of records and topics, and the consumers subscribe to these topics. However, Kafka is a message bus. It's like your classic message bus. It is optimized for high ingress data streams, event-based workflows, and also replay capabilities. Now, I'm sure all of you have heard about how successful Apache Kafka was for open source project created at LinkedIn for big data log analytics. But today, businesses have started using Apache Kafka for different use cases. They essentially look at Kafka to build mission critical applications. And these applications are highly available and responsive and working around the clock. And just imagine if Kafka, and the way that enterprises run today, if the Kafka environment goes down, the whole business stops. Now that's the criticality of the Apache Kafka platform. And how do you achieve it, right? How do you keep a messaging, storage, process in one distributed, scalable, fault tolerant, high volume, technology independent streaming platform? That's a huge ask for any platform to provide, and that's where Apache Kafka has essentially evolved over the years. Just talking of numbers, just LinkedIn processes around 4.5 trillion messages each day. Or let's talk about Netflix. 6 petabytes of data on peak days is handled by this. But I guess the key criticality comes is how do you essentially run such a platform? And that's the beauty of Apache Kalka, where you essentially have producers and consumers. Your producers could be your mobile applications, your enterprise SaaS apps, the microservices, DBs, or your consumers. Your consumers could be real-time fraud detection solutions to data warehouses, to data lakes, or customer 360 portals. However, the streaming platforms needs to have a capability where it is able to deal with changing data sources from data systems, SaaS applications sending data, microservices, consuming data sets, customer experiences in real time, being able to react to it. And how do you essentially architect a platform like this? Now, Kafka at a base, in terms of the Kafka architecture, has primarily the input and output systems. Input could be your log aggregations, metrics, KPIs, and audit trails. And output systems, as we spoke earlier, could be your analytics platforms, your data warehouses, your machine learning platforms. But at the core of Kafka is the Kafka core, which essentially does the capability to script for Zookeeper. It provides utility to create topics, utilities to monitor the statistics. That's the heart of Kafka. In addition, Kafka has different four major components: a producer, essentially, which produces the data; a consumer, which subscribes to the data; the connectors. Connectors are is an integration framework for connecting external data sources or destinations into Kafka. Or Kafka streams. Kafka stream is basically a simple library for application development on Kafka framework. It also provides REST framework for universal access to Kafka using HTTP platform. But however, just imagine, this is a platform for real-time streaming. You're looking at streaming millions of records of data, 2 trillion messages at LinkedIn, or 5 billion events at Netflix. And 1/3 of the Fortune 500 companies use it. And how do you design a platform which is real time, reliable, scalable, and also persistent at the same time? This is where our partners at Confluent have come up. Confluent is an enterprise distribution of Apache Kafka. Yeah, it supports both on-premise and cloud deployments. And Kafka Cloud, it is a fully managed Kafka deployment on Kafka re-engineered for cloud, and it is available on leading cloud platforms, including Amazon, Google Cloud, and Azure. Now, this platforms like Confluent essentially enables management of all the challenges that we described earlier. Now let's look at building analytical models on Kafka. Now we're getting into the machine learning aspects of the presentation. Now the key thing for businesses today is the response times. Your response time could be seconds when it comes to fraud, real-time tracking of cars, transportation, so fleets, or ability to cross-sell on e-commerce portal. The reaction time is seconds, or it essentially impacts your revenue in big time. Or be it consumer service, people essentially, or inventory management. So your response time and the window of opportunity for enterprises to react is reducing drastically day by day. That also brings about the challenge around machine learning. Because in today's session, we are essentially going to focus on existing business processes. Existing business processes are systems and operations that business have, but they want to make it smarter. We're not going to focus on recurring neural networks or object detection or other kind of. We are essentially looking at low-hanging machine learning problems, decision trees, clustering, neural networks, and simple analysis, which can be achieved for operational efficiency and improvement. The goal essentially is to analyze and act on critical business events by improving existing processes. So we are essentially going to focus the next set slides on core business processes and how can enterprises or businesses use machine learning to improve the core business processes. But before we get into this, the key element of any business are the 3 V's: volume, velocity, and variety. Now, and the questions to ask is, how will you add real business value to your big data initiative? How can you build a scalable infrastructure for your analytical models? How will you process and monitor incoming data feeds? How will you deploy models in production in real time, at scale, and with zero downtime. Now, companies have evolved over the years to handle data models. With time, I think if anybody has spent any time looking at SageMaker or any other popular machine learning frameworks, it's easier to deploy, build a model. The challenge comes in how do you take the model and make it react in real time. Anybody can write a Python, not anybody, but it's very common today for everybody to know what building models is. However, the challenge comes in is implementation in real time and having them take real time events. The key is businesses. How do you make business analytics or learnings from business analytics and make them actionable in real time? That's the key challenge that businesses face. And not just that, how do you essentially behave to real-time events? It's a continuous loop where you essentially are getting insights as events happen, and how do you react to those events in real time? I guess that's the biggest challenge where event-based streaming platforms address for businesses today. Now let's look at, I'm sure we've heard of these companies, but over the years, if you've seen Netflix, Uber, PayPal, they've implemented their own platforms. This is way before Confluent, platforms like Confluent, which essentially provide the enterprise distribution of Apache Kafka existed. Companies like Netflix have their own versions of um, scalable recommendation engines built on Kafka. Or Uber implemented Michelangelo, a platform for technology independent machine learning framework. Or PayPal had its own real-time fraud detection framework. Now, all of these projects use Apache Kafka as the streaming platform. And in today's session, we'll look at how some of the commonly used use cases could be solved with this. These companies have been way ahead of the time, used this platform, created a business differential. But the key is how do you as a business take these platforms and implement them in your organization and make a difference at this stage? Now, I just want to mention a key important point. It should not be mistaken that Apache Kafka is only used by tech giants or only used for big data problems, companies which have big data. You essentially can, the huge set of use cases that could be applied to small businesses. It could be applied for systems on any kind of form, either on-premise or in the cloud using Confluent platform. We are going to look at some of these use cases, but the key thing is how do you essentially look at implementing a platform like a Confluent, which essentially enables some of these. Let's go through some of the use cases which can be implemented using a platform, real-time event-driven platforms. You essentially can build your enterprise central nervous systems. Everything in your organization could work on event-driven platform like Apache Kafka. You essentially can make smart apps. Smart apps are real-time apps which can take smart decisions on the fly. You can build your customer 360 systems, your IoT sensor integrations, and we have a huge set of use cases around fraud detection, data replication, or even use cases like digital replatforming or mainframe offloading, as you may say it. Security uses a huge of it, medical use cases around EMR, whatnot. So if you look at the industry today, especially there's a huge usage of event-based streaming platforms. And companies, be it Audi, be it Target, be it Capital One, or even medical companies like Cellmatics, have essentially implemented event-based streaming platforms in their day-to-day usage. And these are for operational needs. These are not machine learning, AI, or deep learning kind of problems. These are day-to-day problems. Fraud detection algorithms have existed for years. Now, how do you essentially make them faster, quicker, and in real time? Security has always been an issue. So most of these companies are taking existing business processes and using machine learning with the help of real-time event management to solve it. But now, how did these systems bundle together? There are big data analytical platforms which essentially organizations use to build the models, get data analysis. How do you take a model embed it into your streaming platform so that as events and streams of events happen in real time, you essentially can provide your consumers intelligence to react in real time. And that's where this presentation essentially is. We are going to walk you in the next few slides. Now, taking a look back at the Apache Confluent ecosystems, Apache Kafka open source ecosystems enables machine learning in different ways. It essentially helps you with model building. It essentially helps you with training data. You essentially can create copies of Kafka's topics or streams in real time and learn it, use it for learning purposes. You essentially can deploy your models with parameters in real time. And it gives you a whole set of services from Apache Connect, where you essentially can connect to any source systems, to defining your producers, to consumers, to red services. It essentially provides you with a whole set of services to be able to react in real time. Now, how do we start? As we move towards the journey towards machine learning, then build a classic build development of analytical pipeline has classic steps. First things first is getting the data access, data preparation. And we'll go through all of these steps in detail in context of how services or machine learning platforms integrate. The key question to ask is, as you're building machine learning platforms, and I'm sure if some of you have already done it or not, where are some of the challenges? And from our experience, we've been essentially in this domain for last 4 to 5 years, and what we've seen is more than the effort that goes for the data scientists to actually model, the maximum amount of time, 80% of the time, goes in configuration, data collection exercises, data cleansing, data quality validation, and analysis and whatnot. The significant amount of time essentially goes in activities which are not necessarily related to machine learning. And platform today, there's a huge set of platform, be it H2O, be it SageMaker, which essentially helps streamline the entire process. Not just that, it essentially provides you with out-of-the-box models that you could deploy as well. And we'll look at them in the next few steps. So, so looking at data access, the key is finding insights between the data sources so that you can create the value for the business. How do you essentially have each of these data sources to speak to each other in ways? And Apache Kafka essentially provides you connectors which can seamlessly integrate into these data sources. The next step, which essentially goes in, is obviously the whole data preparation cycle, where once you get the data sets, the key development that goes in is the data preparation. Now, I think if you're into IT services working with customers or even in-house, the biggest challenge when it comes to data preparation is, even if you're getting the raw data, that who could access management becomes a huge problem. Who sees what data, what time? How are you essentially enabling security? What's the data quality? Has the data systems evolved over the years? Has the data consistent? So while essentially the focus is around building model, that's the output. The key time and the focus is around data cleansing, data quality, and feature engineering. Now, the first things that we have, or any data scientist essentially engages is the moment that you're given some kind of data is looking at data analysis. Doing an exploratory data analysis, looking at what the data says. Traditionally, different kind of tools, including scripting, visual analytics, has been used to essentially look at data. But tools like SageMaker today enable both data visualization, analytics, and essentially give you outliers in the data. Essentially, they define the relationship between data which comes to them, and also could propose you machine learning models which you can apply on the data. So there are things which have been streamlined today which can be leveraged. However, the key activity is building a model. And what is it? It's basically a simplification of truth that helps you make decisions. So either it could be based on past events, past behaviors, histories, and whatnot. Essentially, it enables you to make a decision. Once this model is defined, the key question comes is how do you execute it? How does a model which has been defined based on historical data react in real time? How do you take the model and as the events happen in real time, how do you apply the model on new data sets? Not just that, um, how do you train the data in real time? Assuming that your real-time events significantly change the data and the data characteristics, how do you retrain the data in real time and how do you deploy them in real time becomes a challenge for many of us. Some of the platforms that we've seen evolve today essentially provide you a lot of tools, out of the box tools to help you that. Not just that, you could have data models which arrive, uh, models which essentially have versions of models. How do you manage or maintain versions of model? How do you know which model is better than the other? How do you run models in real time? How do you auto run your models? So some of these platforms like SageMaker, which we're going to go into deep detail, provide you the ability to do all of this with ease. You essentially can predict the performance of one model against the other and validate and deploy the best model in real time. So there's a huge bunch of languages, frameworks, tools. Some would be using classical Python. Others would be using platforms like H2O or TensorFlow or SageMaker. Again, it's a choice, but I think the key elements or benefit of some of the platforms that provide is the ability to train, retrain, deploy models in real time and integrate with real-time streaming platforms like Apache Confluent. Now I'll go back to the slide where we essentially discussed about window of opportunity. It's very important and critical of where you deploy, how you react, and when you react to real-time events. Be it fraud detection, the window of opportunity is seconds to milliseconds. Be it cross-selling, as somebody is essentially closing a shopping experience, be it 2 to 3 minutes. The window of opportunity for businesses to respond, react using machine learning models to upsell. We have seen use cases with our customers where they have been able to increase a revenue of 30% just by implementing Amazon Personalize. There's been a significant ability where we have been able to use personalization to personalize the customer experience and increase the sales. Not just that, let's take the case of contextual application that we were talking about earlier, right? Contextual event-driven applications essentially give you much more than that. Event-driven applications, yes, we've all seen it. It tells you when an event is going to happen. However, a contextual event-driven application, and this is where most of the business applications today are, is you don't you you don't you know, in addition to knowing where your driver is, you also have the information when will he be where you, and when will he be reaching you. So implementing these systems in real time need a event-based streaming platform like Kafka. Not just that, assuming that there are 6 drivers in the vicinity, which driver essentially matches the best criteria based on your need, your destination. All of them is done in real time using various machine learning models. And how do you deploy these models? Assuming that you've used some of the third-party tools or Python scripts or some of the platforms like SageMaker to deploy these models, how do you deploy these models? So one of the things that we have explored is uh, deploying these models as remote web services. So your applications would invoke these web services and what we classically call as AI as a service. So these are services that your systems classically could use proprietary algorithms or third-party algorithms to react. Be it fleet management, classic use cases. Every company has some kind of fleet management systems. Now, machine learning models for fleet management have been basically a commodity today. They are available on the marketplaces on most of the major clouds. You essentially can integrate fleet management model right into your fleet management systems out of the box. And as the time passes, some of this are going to become a commodity. The other way that companies have essentially embedded these models right into the apps. Now, these are, again, the decision whether to interface natively into an app depends on the use case. Depending if the use case is binary or which needs less of data processing, those are the use cases where you could essentially embed the model right into the app. And platforms like SageMaker integrating with Kafka streams make this integration seamless. People take the rest of this time to look at SageMaker, AWS SageMaker, and how does it enable. AWS essentially provides a vast variety of machine learning stack. It has three kind of services: AI services, machine learning services, and the whole framework. We're going to go in detail in each one of them, but let's begin with AI services. As I was mentioning earlier, Amazon provides out-of-the-box AI services that you could plug in into your applications to make them smart, be it text to voice conversions, be it forecasting. You essentially can build in forecasting, integrate forecasting into your web portals so that you essentially can build predictive recommendations or personalization for your customers for their purchases, for their transactions based on their history. Or they also provide Amazon recognition. Let's take the use case. You essentially can recognize images, not just images. You essentially can identify pictures within videos using recognition for vision. You have services for languages. You can use Translate to convert from one language to other, or Comprehend for medical imaging. One of the other interesting service that Amazon Machine Learning Framework provides is chatbots. Uh, Lex essentially is out-of-the-box chatbots which can be integrated into your platforms. The key service that we're going to spend most of our time talking about in the rest of the presentation is Amazon SageMaker. Now, SageMaker is a platform or a framework that Amazon provides where you could build, train, and deploy machine learning models out of the box. Now, just when we say build, it provides you out of the box algorithms or notebooks that you can use out of the box. It also provides you access to a marketplace. There are third-party companies who essentially publish their algorithms and models online, which you can subscribe to as a service. It also provides you a huge set of tools, from data labeling to training your data, to versioning your models, to how do you reinforce learning to deploy them. So a whole set of services around model development are provided by SageMaker. In addition to that, the AWS machine learning framework supports TensorFlow to MaxNet to PyTorch to whatnot. Essentially integrates a huge set of frameworks, and not just frameworks, even infrastructure, be it Greengrass, be it Elastic Inference. It supports even third-party infrastructure as well. Now, looking at SageMaker, it essentially lets you collect and prepare your training data. It helps you choose the right algorithm. If you have your own algorithm, great. Otherwise, it helps you between your algorithms. It helps train, run different versions, and tells you the accuracy of a model. It helps you set up the environments for training purposes. You essentially can create replica environments or data sets in clicks. It helps you train and fine-tune your models, trial and error, A/B testing, and whatnot. Not just that, it essentially helps you deploy your models right into Kafka platforms so that models could essentially run at real time, and it scales based on the business needs. Now we've essentially look at Kafka. However, the key is availability of the whole set of platform that it supports, be it Apache MaxNet, be it TensorFlow, PyTorch, and whatnot. It provides, so you essentially could bring your own frameworks, integrate into SageMaker, and work out of the box. The key is it helps you build using these third-party platforms. You could essentially train it. It lets you help you with hyperparameter optimization of your models by training, replicating, and also Kafka essentially provides you a great ability where you could replicate data sets so that you can use them for training purposes in real time, integrated with SageMaker. You could deploy the models in real time, as we were talking, be it with web services that you could host, which are subscribing to these models, or be it embedded applications with model embedded into them, which are redeployed in real time to take smarter and better decisions based on the data sets. Now, as we've seen our customers take their AI journey, the key thing that we was mentioning earlier is we've seen automation. They have chosen existing business processes to optimize and refine. So essentially improving the quality of the existing services and reducing the cost. That's been the primary low-hanging fruit of the AI journeys. Then we have essentially seen customers adding enhancing features. So this features of product or services, increasing engagement, and attract new customers. So the journey has been automate, enrich, and then invent new products based on this. But this is a classic journey that we have seen customers as they take the enterprise towards AI and event-driven roadmap. But the foundation to most of it is a framework which lets you or enables you to even build your machine learning model. That's the event-based platform like Apache Kafka. And this is basically a continuous loop, right? You essentially you connect your technology initiative with your business outcomes, you advance your strategy and organize for success. And we've been essentially helping them in many ways to achieve this using these platforms. With this, I'll hand it over to Peter. Peter?
Thanks, Nitin. And again, thank you all for attending. We'll give you a few next steps. A copy of the webinar will be made available to all participants. If you'd like to make note of this at https://ctepl.com/events. If you have any questions that are particular to this webinar or furthering your information around it, we hope that we've provided you some foundational information around Apache Kafka and the Confluent piece. If you'd like to evaluate Confluent and the Apache Kafka platform, SageMaker, we can do that via POC or we can do demos. Send us an email, give us a call. There are possibilities that still exist in this fiscal year, which ends at the end of December. So time and money is running out, but there are marketing development funds available from our partner companies to do joint AWS, CT, and even Confluent funded POCs. Connect with us, connect with sales, and we can discuss the specific needs. Again, thank you all for attending. We got you out in about 40 minutes or so. We hope that you got some good information, and if we can help with anything more, please let us know. This concludes our webinars for the year. We will pick up again in January. So stay tuned. We'll continue our Beyond Predictions series in 2020, and we'll continue to build out our informational webinars, mostly dedicated to the idea of data analysis, using big data, AI, machine learning, and data streaming. Thanks again. Hope you have a great day, great rest of the week. If you're in the east, even down to the southeast where we are, stay warm. It got cold last night. Thanks.